Now we can finally move on to the main course, how functions and closures capture variables. Take a close look at the function makeCounter below. The code is pretty short, but it will require some close inspection to understand it the first time. What's special about this? Well, it returns a function, an int maker. That's okay, there's nothing really special about that. We've seen that functions and closures, and by the way, here I'm using function instead of a closure syntax simply because the syntax is simpler. That's the only reason. It would work exactly the same with a closure. So we're returning a function or closure. Remember, it's the same thing. And since functions and closures are class objects, we can return them from another function. So far, that's normal. Just like some machines create other machines, some functions can create other functions. There's nothing special about that. What else is interesting, or at least unusual? It has a function within itself. So it contains a function defined within makeCounter. Well, don't panic, that's normal too. Just like you can have machines that contain other machines, and these are only visible from within the containing machine. Think of your radio inside your car. So no big deal there. And it's actually useful and good practice to break down a long function, not this one, but a long function or a complex one, into small, simple functions by using inner functions that do part of the total job. What else is interesting about this? The really, really interesting, funky part, by the way, this should be this, is that adder, the inner function, can access this variable that is defined before it. Not only can it access it, but it's changing it. It's adding 1 to that. That's what we call variable capture. So to understand how this works, let's create 2 closures of type intMaker by calling twice makeCounter and save them into 2 variables. So both counter1 and counter2 take no arguments and they return an integer. Think very carefully what the output should be when I call counter1 thrice. Try to think before using the playground. So the first time, n will have value 0. We add 1 and adder returns 1. Let's see if it's true. And what happens when I call again counter1? What do you expect? Let's give it a try. So as you can see, when we call it again, counter, which is actually a type of adder, keeps adding 1 to n, and that value remains there. So we get 2, 3, 4, etc. And now for the grand finale, what do you think this would return? Calling counter2 for the first time. Think before trying it. And as we can see, it returns 1. You might have expected it to return 4. Actually, that would not be very useful because that would mean that every function adder shares this n. The first languages that implemented this variable capture feature did behave that way, but it was soon realized that this was a bug. It was not a feature. So right now, every single closure that we return from makeCounter takes its own copy of all the captured variables. So every time an adder is created, it takes a copy of all the captured variables. Therefore, each closure has its own copy of the environment. And the environment means all the values of all the variables that were captured. This is done for safety and also to keep you sane. The value of a variable will never change out of the blue because somewhere some closure decided to change it. Everybody has its own copy. Let's wrap up. We've learned quite a few things about Swift in this lesson, so let's recap. First of all, functions and closures are the same thing. We just have 2 different syntaxes to express one same thing. Functions and closures are first-class citizens of our language. We can treat them like any other type. And also, functions and closures capture variables defined before the closure or function is defined. It might not seem obvious to you at this point, but those 2 last features make Swift a far more powerful language. They are the base of a different style of programming called functional programming. Its popularity is increasing a lot lately. However, you won't need it to finish the nano degree or even land your first job. So don't worry, it's something that you can learn later on if you want. If you're interested, you might want to check any of the books that are linked in the instructor notes. They are introductions to functional programming. And in the meantime, we'll move to the next chapter, which deals with Grand Central Dispatch. This is a library that allows us to create background tasks with great ease. This is vital to ship great apps and avoid being rejected from the App Store. Our newly gained knowledge of closures would make understanding GCD a breeze, so let's move on and learn it.